Hello CS11, this is lecture 22, where we'll be going over these topics over here. Alright, so let's start. So the first thing that we'll be looking at for this lecture is default arguments. So for that, let's first look at yung enumerate function. We've encountered this function several times throughout CS11. So how do we actually implement this function over here? Well, for that, you have several ways you can use that function. So one is the one we're most familiar with. So if you give it some sequence, it will enumerate the values in that sequence. So let's say let's run Python, and I have some sequence here, A, B, C. So I have this sequence, and I have for index value in enumerate sequence, print the index and the value. So here you see that for each element in the sequence, I have my corresponding index over here. So this is for the standard usage of the enumerate function. Now, what if you want to use it like this instead? So here, instead of just giving it the sequence, here you're also giving it a starting index. So let's say instead of starting at 0, you want to start at 1. What you would do here is you would have another argument to represent the starting index, and if I run this, now you see that 0 becomes 1 here. So now we're starting the count at index 1. So how do we actually implement yung enumerate function so that it can work like this and like this? Well, one solution is to use variadics. So remember from one of the previous lectures, variadics allow your function to accept any number of arguments. So here we're doing a conditional check on the number of arguments that you get in the variable args. So if you get one argument, then that argument is just your entire sequence. So you have sequence is equal to arguments. Remember that arguments here is a tuple. So you're destructuring this tuple of one element, where that element is yung sequence itself. So your starting index is 0, and you do what you need to do over here. On the other hand, if you get two arguments, so for this situation here, so what you would do in that case would be you would destructure yung tuple first to the sequence as well as the starting index. So it's very similar to this first one, except you're also capturing the value of the starting index. Okay, otherwise they're probably using the function enumerate not in the way that you expect. So here you raise an error. So this does work if you want to make enumerate work like this and like this, but hopefully you'll think that this implementation here is kind of ugly. If you wanted your function to support more arguments, for example at least 3 or something, then this would get even worse. You would have to support another branch for the case length of args is equal to 3 or something. So is there a cleaner way to do something like this? And for that, what Python has is what we call arguments with default values. So let's look at what that is. So here, this is a function definition where aside from our sequence input, we also have this additional argument over here. So we have start, and that's equal to 0. This equal to 0, this is yung default value of this argument. So this start is also an argument, just like sequence, but it also has a corresponding default value over here. So the nice thing with this is that if you omit or if you leave out yung start argument, it Python is going to assign the default value of 0 to start over here. So let's look at a different example here. So you have a function f with 2 arguments and 3 other arguments with default values. So this c, d, and e, each of them can have a default value, as you can see over here. So that means let's define this function. So define f a b c is equal to 100, d is equal to 1000, and e is equal to 10,000. So I'll return the sum of those 5 numbers. So what that means is, if I try to run, let's look at these examples here. If I run 1 and 1, yung a and yung b, each of these will get the values 1. And since I have no more arguments here, the rest of these arguments get their default values. So this will give us 11102. So this plus this plus this plus the 2 over here. So if I put an additional argument here, now yung c, instead of getting 100, it gets the value 1 over here from the actual function call. So this time, yung result is going to be 11,000 from d and e over here, plus the 3 that we get from here. Next, we have this function call. If I do this, this is now 10,000, the default value of e, plus the 4 over here. And of course, if I have an actual argument for all 5 arguments here, this is now 5. So you don't get any of the default values here, you use the ones over here. So that's functions with default arguments. Now one caveat here is that if you're going to do this, have a function with default arguments, be careful not to use a mutable value as your default value. So the reason for that is, I guess it's easier to just show you. If I define f with a and an initial value for this list here, and I do list.append a, then return the list. Alright, so this at first glance looks pretty normal. If we do f or L is f of 1. So L now is going to contain 1 since you appended 1 to this empty list over here. So what happens now if I do something else? So let's say the second list is f of 2. If I get the second list, you'll see now that here, instead of getting a list with just the number 2, I have a list with both 1 and 2. So aside from 2, it also contains this 1 from a while ago. Why is this the case? So that's because yung empty list that you see over here in this function definition, this stays the same throughout all function calls. So if you're appending both 1 and 2, you're appending those values to the same list over here, which is why you get 1, 2 in L2 over here. So be very careful. Don't use a mutable value as your default value. Okay, so if you really want to, what you can do as a workaround is to set yung initial value to none. So here, back in the function definition, we set this to none, and here inside we have a check. If the list is none, then just set it to the empty list. So this is another workaround for if you really want a empty list as a default. So there, if you try it like this, let's run this. So L is f of 1 and L2 is f of 2. So now you can see that it works now. So although the only caveat to that is, since you define this argument like this, it is technically also possible for a user to do a function call like this. So f of 1 then none. So from the user side, this looks pretty unintuitive, but since you define your function like this now, you don't really have a choice at that point. So yeah, just keep that in mind. Usually in terms of functionality, this is perfectly fine though. It just looks a bit weird. Okay, so back to the enumerate function. So the way enumerate actually works is that yung second argument niya actually has a default value of 0. So yung second argument is start, and we can explicitly indicate what we want that value of start to have. So if we want the starting index to be 1, we can set start is equal to 1 after passing in the sequence over here. So let me try to copy this. So let's see. If I run this, we'll see that yung starting index is now 1, then it goes onwards. So this is how we can explicitly state what we want the starting index to be. So if we want it to be something else, 11 for example, it's going to start at 11 like this. So this part over here, where we explicitly write out yung argument name, we have an equals, then we have its value. This is actually new syntax. So we name yung argument here explicitly. And when we do that, this argument here is what we actually call a keyword argument. Okay, so just to make that clear, if we have this example here, yung start in a keyword argument here, this is a different thing from, let's say you define a variable start here. Variables are different from keyword arguments. So in this case, this isn't going to give you an error or something. It's just going to set yung start to yung value over here. This will evaluate to 1. So this is start is equal to 1. Alright. So another function that also has keyword arguments is print. So for example, there are these example calls over here. Let's try each of them out. So you have print. Let's say you have A, B, and C. So the standard way of using print is just printing out some stuff in succession. If you want to separate them with something, you can explicitly indicate that. So this puts this string in between consecutive strings over here. We can also use end. So if we put some string over here as our end, that will put that specific string at the end of all of these initial strings over here. So you can combine those. If we do this, this will give us a dash b dash c, then it ends it with a question mark. So as you can see, when it comes to keyword arguments, you can also rearrange them. So if I write it like this, it will give me the same thing. So this is typically how you can use keyword arguments. So print also has some other keyword arguments, but we'll look at those in one of the later lectures. Okay, this is yung full signature of print. So the stuff you want to print out, and these keyword arguments over here. Alright, so what if instead of just some specific number of keyword arguments, we actually want any number of keyword arguments? So just like how we can have any number of normal arguments over here using the star, how can we have any number of keyword arguments? Well, the key to that is to use a double star. So a double star will now make it so that you can pass in any number of keyword arguments. So let's actually try this out. I'm going to define a function that takes in any number of keyword arguments, keyword args. And I'm going to explicitly print out what those keyword arguments are. So let's say I do f, a is 1, b is 2. You'll see that what we get back here is a dictionary. So this is a dictionary where the keys are yung keywords, A and B, and yung values are their, well, corresponding values. So A here has a value of 1, B has a value of 2. So even if I only have a single argument, it gives me a dictionary with a single entry. If I give it nothing, it just gives me an empty dictionary. So this double star makes it so that this variable over here is a dictionary. Okay? So if we combine that idea with the single star, for any function, we can give it any number of normal arguments and any number of keyword arguments using this syntax over here. So now you have args and quargs. This is for keyword arguments. And let's try that actually. Args dash double star quargs. So we print out args and quargs. So let's say I have 1, B is 2, C is 3. So the args will have a tuple consisting of this one over here, while yung quargs will give me a dictionary with these entries from these inputs here. Okay? So using the names args and quargs is the standard convention in Python. So if you want to have a function that has any number of normal or keyword arguments, you would use these names. Okay, so one important thing is that you cannot mix up yung args and quargs. If I do this, you'll see that Python starts to complain. So if you're going to use any number of arguments or keyword arguments, make sure that the arguments come first before the keyword arguments, like this example here. Okay, so let's look at a few more function calls. If I only have keyword arguments, yung tuple is going to be empty. If I only have standard arguments, yung dictionary will be empty. Okay? So that's how keyword arguments work. So since this evaluates to a dictionary, that also means that in a function, you can also splat a dictionary for the keyword arguments of this function. So that's also the reason why splatting a dictionary uses the double star. So remember when we first went over dictionaries, we said how, let's say if A is A1, B is B maps to 2, and if we wanted to combine those dictionaries, we would do something like double splat A, double splat B. Now the reason for this is in order to match with the keyword arguments syntax over here. So we can splat this dictionary into this function here. This will be the same thing as giving it an argument foo with value 5 and an argument bar with value 6. Okay, so this is the expected output of this function call. Okay, so that is for keyword arguments. Alright, so let's now look at one other thing. So next, we'll be looking at functions. So far, throughout CS11, we've worked with quite a lot of functions, hopefully. So the way that Python runs functions is, or just programs in general, is usually from top to bottom. So let's say we have this program over here. How Python runs this is it looks from top to bottom here, and it eventually evaluates this print over here. So the point that I want to make for this part of the lecture is that when it comes to these function definitions, these are actually very similar to assignment. So for example, we usually assign values to variables like this: x is 5, y is 6, and so on. When it comes to defining functions, something very similar is actually happening. So you can think of this part over here as if I wrote something like this. So I have a variable square that has a value of whatever this function is meant to represent. And same thing for this square norm function over here. So what Python is actually doing when you're making function definitions like this is something that looks like this. So there are variables and they have these corresponding values. So the point of this is that just like any of the other values that we've seen so far, functions are also values. So we already know all the way back from lab lecture 0 that these standard things are, well, values. Ints are values, strings are values, and so on. The main idea now is that these functions that we've been making all this time, all of them are also values. So if we try to define a function, let's say square of x return x squared, and we try to print the type of square, you'll see that this has its own type. This is a value with a type of function. Okay? And if we try to get the type of square, while we give it some input, this evaluates to an integer. So this is expected since square of 5 does return 5 squared, which is an integer. But note that if we got rid of those arguments, we just give it the function name, that is a value that has its corresponding type. Okay? So that's nice and all, but now that we know that functions are values, what does that actually allow us to do? So one nice thing is that, let's look at this example here. Yung sorted function, this sorts some sequence of values. So here, when we try to sort these 3 strings over here, it sorts them in alphabetical order. So M, since A goes first, then I, then real. So this sorted, it turns out that this actually has a keyword argument. And that keyword argument must be a function. It's not some integer string or something else. It's a function. So what that means is that if you pass it a function, it will sort these strings using that function. So if we wanted to sort these strings by length instead of by alphabetical order, we could do something like this. So we have sorted, then the sequence, then we have the keyword argument key, and the value niya is a function, len. So this is the length function that we already know. Note that, let me get this. This is not the same thing as if I did, let's get all of this. This is not the same thing as calling the function. So this is something different from this. Here you're passing in the function itself as the value corresponding to key over here. So if we do that, you'll see now that this is sorted by their length. I is the shortest string, so it goes first, then so on and so forth. So there. Again, note that you're giving it the function, not a function call. Alright? So what sorted actually does is it, inside its implementation, this is the function that's in charge of actually calling this length function. When we're making this function call, we're not yet calling the length function. That's the job of what happens inside the sorted function itself. Okay? So this is also available if you use .sort instead of sorted. And yeah, it does the same thing over here. Okay? So since these are functions that take in other functions as arguments, we call these higher order functions. On the other hand, yung length, for example, this is what we call a first order function. Okay? So first order, since it itself is a function that does not call other functions. For sorted, it's a higher order function since it's a function that calls other functions. Okay, again, all of this stuff about functions using other functions, this is possible because, again, functions are values. Okay? So what if we want to do something else? If you want to sort them by some other metric, for example, their last letter, well, to do that, we would just need to make a new function. So something like this. We make a new function that returns yung last letter of the string, and we use that as yung function call, or we use that as the function that we pass into the sorted function over here. So here, if we give last letter as the key, it will now sort these three strings via their last letter. Okay, what else? So what if we want some other slightly more complicated way of sorting? So here, first by absolute value, then by actual value. So this list should become this list over here. Well, for that, what we can do is do the same thing actually. Make a new function and just change what you use as the key. Since we want to sort by absolute value first, yung first element ng key should be the absolute value of the number, while yung second element should be the value itself, the actual value. So if you want to have several layers of sorting, just like what we have here, you usually can use a tuple for that, since the way Python sorts tuples is by first looking at the first element, then by looking at subsequent elements. So if you want to sort by this first, then you put it as the first element of the tuple. Then if you want to sort by this next, that's what you put as the next element of the tuple. Okay, so this is how you sort in a different way. Alright, so if you notice here, we're making this function name, this very long function name, just so we can sort the sequence like this. So this is, if you have more of these functions like this, doing this can get pretty tiring. Having to write the function name in full like this can be pretty tiring. So in order to work around that, what you can actually do is use what you call anonymous functions. So anonymous, since these are functions that don't have a name. What does that mean? So here we have a function, and it has, as you can see, no name over here. This lambda, this is not yung name ng function. This is new syntax, a new Python keyword that we use whenever we want to make a function that is nameless. So here, the input is number, and yung output niya is this tuple over here. And all of this is yung anonymous function. Okay? So why is it called lambda out of all of the Greek letters? Well, this is mainly due to history. The one that actually motivated yung name na lambda is yung si Alonzo Church. So Alonzo Church came up with what we call lambda calculus. For those in CS, you'll be seeing this in one of the future CS courses. But yeah, we use lambda since, well, it's named after yung lambda calculus ni Alonzo Church. Yung lambda calculus has something to do with the fact that we use functions as values, which is, yeah, another reason why we use lambda. Okay? So other languages might use different names for this. So for Python, we use lambda. Okay? So lambdas, or anonymous functions, they do have a limitation. So the limitation is that we cannot put statements. We can only have expressions. Remember, statements are like yung if-else, for loops, or try except. While expressions, these are yung, for example, yung ternary expression. So one if true, else true, something like this. This is an expression since it evaluates to a value. In Python, only expressions like this can be included inside a lambda, not other stuff like this. Okay? So this is actually just a Python thing. If you have other languages, if you work with other languages, it is likely that you can use these statements if you have anonymous functions. But for Python, we can only have expressions. Okay? The main reason for that is because Python is indentation based. So a statement like this would have to span across several lines. Lambdas are usually meant if you only want to define a function in a single line. So yeah, that's one reason. Okay, so because of that, try to use lambdas only if you have a simple function. So for example, yung previous examples natin for sorting, those are examples where you should just use lambdas instead. Okay? If you have a more complicated function, just make a normal function definition, like this one over here. Alright? So that is for lambda expressions. Okay. So for the last part, I believe, we'll now be looking into something slightly different. So here we have a program, and this is meant to demonstrate one of the usual errors that you run into when programming. Okay, so let's say we have this line. We're meant to enter our age here. So let me enter my age. Here we have this statement here. And as you can see, we now encounter an error when we try to run this statement here. So this is a type error. Since yung age that we get over here, this is actually a string, not an integer. So you can't add a string and an integer. So this type error, the nice thing about type errors compared to other kinds of errors, like syntax errors, for example, something like this. So the nice thing about type errors compared to other kinds of errors is that they can actually be detected without even running the program over here. So in other words, there are other programs that can statically analyze your own program. Let's say we have a program over here. So age is input, enter your age. Then we have new age is age plus 1. So if you set up your editor or whatever you use, it is possible for other programs to analyze whatever you're writing over here and see that, hey, you're trying to add some string and some integer over here, which is illegal. So depending on the editor you're using, it is possible for them to show an error already without even running this program over here. Okay, so how does this actually happen? How do these other programs actually detect these type errors that happen while you're writing your code over here? Well, this is possible, as I've already mentioned, but one thing that you would likely have to do is you would have to annotate your code with what we call type hints. So type hints, as the name suggests, these are hints that indicate the types of different values in your program. So if you have type hints, what type hints look like are like this. So if you do that, what Python can do, or what external programs can do, is that they can detect type errors based on what you put over here. So here you have this input function that's meant to return a string, but here you're giving it a type hint of integer. So what that means is that you expect this to be an integer, but in reality this is actually a string. So the external program, which we call a static type checker, is meant to catch mismatches like these. Okay, these are some of the common type checkers that you might use. And note that these are third-party libraries. These are not built into Python itself. So you will have to install these if you want to actually check for the types in your program. Okay, so again, a type annotation looks like this. After the variable, you have a colon, then the type. Alright, so these are type annotations. So these bits, these are actually ignored when you're running the program. This information is meant for the static type checker, not for Python itself. So even if I try to run this, let's save that and try to run hello.py. You'll note that Python doesn't immediately give us yung type error, since it doesn't actually care about the type hints that we give it over here. Yung type hints, those are what the static type checkers look at, not Python. Okay, so if you have a static type checker, you can run them in a similar way to Python. So the type checker, then your program over here. Okay, so whenever you run one of these static type checkers, what they actually do is they don't run the entire program. It just reads, it doesn't run, it just reads yung source code na to as a string. Okay, so doing it this way instead of actually running the program, this is a lot faster, since let's say I have an infinite loop over here. If I had something like this, and if you explicitly run the program, it's never going to end if you actually run all of this. But if you have a static type checker, what it does is it doesn't actually explicitly run all of this. It just looks at what the program, how the program is actually structured in terms of text. Okay? So, as I've been mentioning now, this idea, static type checking, this is possible because of one very important idea. Code is just text. So just like yung, if I have any random text file here, so this is some text, these two are the same thing. It's just a bunch of characters put together. It's just that when it comes to Python files, these characters are arranged in a way that can be ran as a Python program. Okay? So that means that external programs can read this as if it was reading a text file over here. Okay? So that means that it can analyze the characters, the words, the stuff over here, without actually explicitly running it the way Python would run it. Okay? So that's the problem that these static type checkers can solve.